In this video, we're going to be taking a look at two of the basic ways that we can do movement in 2D style video games. So we're going to be looking at moving the transforms X and Y coordinates directly, or by using the built-in physics system inside of Unity. So what I've done here is made a simple scene. I've dragged in a little spaceship sprite here that I had on the computer, and we're going to look at how to get input from the keyboard first and then applying that to the two different ways of movement. So if I want to make this spaceship move, first thing I need to do is set up some inputs so that I know which keys I want to press and have control my ship. So we can go to Edit, Project Settings, Input, to get our input manager. And inside of here you have these things called axes. And this is totally customizable inside of Unity. So we have the horizontal axes right here, which is already set up to be working with the left arrow and the right arrow and the A and the D key. And of course we can go in here and change these to any keys we want, but these are set up for standard movement controls in most games. We're going to leave them the way they are. So this is the horizontal one for left and right movement. We also have this one called vertical, which is set to the down and up arrow, and the S and W key for the up and down directions of movement. And again, those are standard, so we're just going to leave them the way they are. So we're going to make a script here, and we're going to access these axes in our input manager to get some information back from the computer as to which buttons are being pressed, and we can use that to control our movement. Alright, so we're going to make a script here. So we'll create a new C# script. We're going to call this movement. Alright, so we're going to open up this script in MonoDevelop. And the first thing we're going to want to do is get those inputs from our input manager. So a very important thing to know is that whenever you're getting keyboard input or any other kind of input from the player, you want to be checking for that in your update function. This is the function that runs every frame, so as soon as a key is pressed, we want to detect that. So we're going to do that in our update function, and we're going to get the values out of our inputs and store those. So the values out of input for axes are actually floats. So let's set up a float variable here called horizontal, and we're going to set that equal to Input.GetAxis, and then we have to tell it which axis we want. So this is going to be horizontal. Alright, so this right here has to match up exactly with the name in our input manager. So if we go back over to Unity here to our input manager, so again, project settings input, this right here, horizontal, spelled and capitalized exactly the same in my script, because what I'm telling the script to do is go to the input manager and find an axis with the name I specified. So find this axis and return me its value. Now Input.GetAxis will return a float number between a -1 and a +1. If you're on a negative key, in this case the left arrow or the A key, you're going to get a -1. If you're not pressing any of the keys in the axis, you get a 0, and if you're pushing the positive key, which would be the right arrow or the D key in this case, then you're going to get a +1. So we're just storing that number because we can use that to apply our movement here in a minute. Let's also get it for our vertical. So we'll make a variable called vertical here, float variable. And again, we're going to go input, get axis, and then this time we want the one that's called vertical. Again, have to spell it exactly the way that it's in the input manager. And that's going to get us the values based off of which keys are being pressed. Okay? Now that we have this information, we can apply it to movement. So the first style of movement we're going to look at is where we move the actual transform. We just change the XY coordinates of our 2D object in the game. This doesn't apply any kind of physics. It just is a direct grab the object and move it to a new coordinate spot. So to do that, we can use a command called transform.Translate. Transform.Translate will move our transform in the direction and distance of the translation. The translation is a vector 3. So vector 3 is an x, y, z amount that we want to move. So the first position in vector 3 is the x. So how much do we want to move on the x? Well, that's going to be controlled by my horizontal axis, my left and right arrows and the A and D key. So I'm going to tell it to move by horizontal. I'm going to take that times time.delta time, because that will chop that movement up over a second's worth of time. So we don't want to do frame-based movement, because then frame rate will control how fast you move. So this will chop it up over a second's worth of time. And then since horizontal is at most going to be a 1, we want to take that times some sort of a speed variable that will allow us to control how many units per second we're moving. So of course that's a variable we have to make up here at the top. So let's make that real quick. Let's make that a float. We'll make it a public float so we can play with that in the inspector. Alright, so that's going to take care of our side-to-side movement. That's the x. So now I put a comma, and now I'm going to be working on the y. Okay, so y is up and down, so that's going to be my vertical. So I'm going to put vertical. Again, I'm going to take that times time.delta time so that it does this on a time-based movement instead of a frame-based movement. And again, I'm going to take that times my speed. Alright, and then we do a comma, and now we have the z coordinate. In a 2D game, we don't move on the z, so I'm just going to put 0 float in there so that we're not moving any on the z. So transform.Translate is now going to move us horizontal on the x, and by our vertical on the y, and nothing on the z. So if I save this and go out and test it, I should have control of my spaceship now. Let's clear out those. Okay, so I'm going to go to my spaceship. I'm going to go ahead and give him this movement script. Let's give myself a speed, let's say maybe 10, and let's hit play. Alright, so now if I push the up arrow, I move up. If I push the down arrow, I move down. Right and left arrows, WASD keys as well, are working just fine. So this is literally just taking the object and moving its position in the XY grid here. Just changing coordinates. There's no physics in here. There is a bit of easing, so when I let go, it doesn't stop instantly. It takes about half a second to slow down, and that's just to give a little bit of a feel of some momentum here. Makes it feel a little more realistic to the player. There's a little cushioning there. That can be turned off if you don't want that, but that is just moving around with transform.Translate, just changing the coordinates. Okay, so let's say with my little spaceship here, instead of just moving left, right, up, down like this, we actually want my left, right to rotate the spaceship so he's pointing in a different direction, and then forwards and backwards will just move him forwards or backwards along whichever position he's pointing. So to do that, we're going to talk about rotating our object. So transform.Translate just moves the transform. We want to rotate the transform, so what we would do then is we'd say transform.Rotate, and again we're going to give it a vector 3 that's in Euler angles. Euler angles are just normal degrees that we use. So 90 degrees, 45 degrees, however much you want. So you have to tell it how much to rotate it every frame in regular Euler angle degrees. So this time I'm going to make a change here, because instead of horizontal moving me left and right, I'm going to take that out of there, because now I want to move 0 side to side. I'm not strafing, I want to turn. Alright, but then transform.Rotate is going to need to, let's paste this in here, is going to rotate us by horizontal. Okay, so again, this is a vector 3, so on the x we don't want to rotate at all. On the y-axis we actually don't want to rotate at all. What we want to rotate on is our z-axis. The z-axis is the one that goes straight through the screen as you're sitting looking at it. That's the one we want to spin our player around on. So this time I'm going to take that times, make that horizontal times time.delta time, and then I'm going to want a different speed here. So let's make a new one called turn speed. to control how fast we can turn. So again, we'll do a public float turn speed up here, and now we can specify that out in the inspector as well. And this will now cause us to just move forwards or backwards with those vertical access keys, and to rotate left and right with my horizontal keys. So let's save this, go back over here into Unity, and then let's go to turn speed here. Now this is in degrees, and because I'm taking it times time.delta time, it's degrees per second. So let's make it something like 90 degrees per second. We'll see how that feels. So when I hit play now, and I push my left or right arrow, I rotate. Okay, now it's inverted right now. If I push left, I'm actually rotating to the right. Right rotates me to the left. So depending on if you want your keys inverted or not, that's an easy fix. If I want to make it so it's not inverted, I could just simply change my turn speed here to a negative number. And now if I hit play and go to the left, I rotate left. Right rotates right. So now I've got that. And then I can move forward, and I can just kind of zip my little ship all over the place. And he's moving according to his local axes, so that's nice. Whichever way he's pointing is the way that he's going to move. So that gives me control over rotation. So strafing, you would use transform.Translate. For turning, you would use transform.Rotate. All right, so again, this is just changing the actual coordinates and degrees we're rotated at directly. If we want to do physics-based movement, that's what we're going to look at next. So for physics-based movement, we're not going to use our transform.Translate or transform.Rotate. We're actually going to do something else here. We can get our axes just exactly the same way. That's just telling us which keys are being pressed and giving us directional control. But what I'm going to need to do physics-based movement is I'm going to have to make a public rigid body 2D variable, and we'll just call it RB, because I'm going to have to access the rigid body that I'm going to put on my spaceship here so that I can add forces to it. So we've got that. Let's go into Unity here. Let's go to my little spaceship, and to use physics I have to add a rigid body component. So let's go component, physics 2D, rigid body 2D. Now I don't want gravity in this game. I'm not jumping. This isn't a platform game, so I'm going to turn gravity to 0. But otherwise I can leave all this the same. Okay, I can just leave it as defaults for right now. And this adds the ability for us to use the built-in Unity physics system with our little spaceship here. Now this variable I made right here, the rigid body 2D, it needs this rigid body right here. So I can just actually grab this rigid body and drop it right here in the box, and it'll make the connection. Okay, I could have also just grabbed my player from the hierarchy and dropped them in here, and it would have stripped out the rigid body that way as well. And there's also a way in code that we can just, in our script, just tell it, hey, go grab your rigid body. But this is probably simpler just to drag and drop right now. So we made that connection so that when I ask for RB in my script, it knows I'm talking about the rigid body on this object. All right, back to our script. We're all set up to do this now. So if I want to move left or right, up or down, I have to do some add some force to my rigid body. So I can say RB, which is my rigid body, dot, and then there's a couple of options I have here. I'm going to use add relative force. What add relative force will do is it'll add a force relative to the local coordinate system of my object. So as I rotate him around, it'll push him along the direction he's facing instead of just always straight up towards the top of the screen. Now I have to give it a vector 2. A vector 2 is like a vector 3, except it doesn't have a z coordinate, so it's just an xy. So in this case, I want to, let's say if I wanted to strafe side to side or move up or down, I would, for the x, I would feed it in horizontal, and I would take that times my speed, and then I'm going to take that times time.delta time, and then for my y, I would give it my vertical, and take that times my speed, and take that times time.delta time. Alright, again, I'm doing time.delta time because I'm actually moving in the update function. Technically, if you're using rigid body movement and physics movement, we should be working in a function called fixed update. which makes life a little more exact for our computer here. But we can get away with this for now. So let's save that. Now I should be able to move side to side and up and down in Unity here. And okay, we got a bit of an error here. Alright, so one more thing we have to add here so that we don't get an error is we actually have to specify that we're making a new vector 2 right here. So let's go ahead and just enclose all that into this kind of a setup. So now I'm telling it, add relative force, make me a new vector 2 that has an x value of this and a y value of this. And then that will make Unity happy here. So let's go back in and we'll clear out our errors here. Okay, so now if I hit play and I push to the left or to the right, you notice how I start moving right and I'm holding down on the key. The longer I hold, the faster and faster I move. When I let go, I just keep moving at the same speed. Okay, so I gave it a push. There is no friction set up right now, so he's just going to slide this way forever until I go the other way. Now, if I start pushing to the left, it's slowing down. Oh, we just went off the screen. Let's see if I can get him to come back on. But here we go. So it took a while to overcome the momentum because I started pushing from the other side, and now he's moving faster and faster and faster and faster because every frame I'm adding a little bit of force to him. Okay? And again, I start pushing back to the right. It's going to take forever to slow him down. Okay? So then we can also move up and down like this as well. So here's up. Now, it's taken quite a while to get some speed built up, so if I want to make that a little faster, I just have to change my speed here to something more like maybe a 100, and now I've got a little more responsiveness. But anyway, I can go left, right, up, down, and this has got momentum and inertia built in, because we're using the built-in physics system. Okay? If I want a little bit of friction in my game, that's over here in my rigid body. So linear drag is my friction. If I turn that up to something like a 1, you'll notice how the spaceship now gradually slowed down. Angular drag here has to do with how quickly I stop spinning, and we haven't done spinning in here yet, which is called torque in our physics system. But if I give it a higher angular drag setting, it'll stop spinning quicker. So think about this as the friction in your game. Alright, so let's go ahead and add the turning, because again, maybe I want to actually be able to steer my spaceship around, or maybe I want to kind of make my steering a little bit more like those old arcade games like Asteroids. We can look at that too. But to turn or rotate with the physics system, we would say RB dot, and then we're going to add torque. And then torque is just a float amount. So how much force as a float do I want to add? So again, I can add that in using my horizontal keys. So if I get rid of this here, matter of fact, I'll just cut it out and put a 0 here, because now I don't want to move side to side. I don't want to strafe. I actually want to turn with my horizontal keys, and I paste that into here. This will now allow me to turn. Okay, and let's change that to turn speed so we can control how fast we turn and how fast we thrust separately. Okay, so now I'm adding a torque using my left and right arrow and my A and D key times my turn speed and chopping that up over time. So let's go back in and see what happens now. Okay, so if I hit play and I push my left arrow, there I go. And the longer I hold it, the faster and the faster and the faster I'm going to spin. When I let go, I keep spinning at that rate. Now there is a little bit of angular drag here, so slowly over time I will slow down. I'm starting to slow down a little bit now. You can see if I increase my angular drag, you'll notice that I slow down faster. So you could turn this all the way up to close to a 1, and then you've got a lot of angular drag. So you can control how much momentum you want to have on a spin with that. And then if I face this way and I start thrusting forward, I'll move in the direction I'm facing. That's because I'm using the add relative force. And then to slow down, of course, I've got to turn around the other way, which is hard to do if your controls are a little too finicky here. But now I'm thrusting the other way, and you can see it's computing all those different forces on my ship. Alright, so it's kind of hard to control, but it is a more realistic type of control setting that you would have if you were out in outer space and actually piloting a real spaceship. So this is using the physics system. Now for old school games like Asteroids, you would use probably a combination of these things. Either that or you would turn your angular drag up pretty high so that when you stop thrusting to the left or right, you would stop pretty much right away, like it does here. So you just turn your angular drag up a little bit. In a game like Asteroids, you're thrusting forward, but then to stop or go the other way, you've got to rotate all the way around, and then you've got to thrust in the opposite direction to stop. So these controls are pretty sluggish like this, so you'd have to play with it some. But that's the basic idea. You can also mix these together. So for instance, if I wanted to have the forward motion like a rocket thrusting, but I wanted to turn more quickly and not have the physics added to my turning, I could turn off this and turn on this, and now I can rotate my transform directly with transform.Rotate while adding my forward and backwards forces with my rigid body. So you can kind of combine these to get some good control of your game objects. And a lot of times in games, real life physics isn't that much fun to play, so we kind of cheated a little bit here to make it a little more controllable. So now I can rotate, and as soon as I stop pushing, I stop turning. And if I thrust, let's give myself a little more thrust here. And if I start moving, and I'm like, oh, I want to go back the other way, I can turn around a little quicker and then counteract that thrust and move down like this. Okay? And again, if I want friction, I can add linear drag. See when I added that linear drag there? Now my guy stops. Now the problem with adding drag is you're going to have to push a little harder to get your top speed. So you'd have to up your speed a little bit, but now I stop after a bit because I've got some drag. Again, this is friction. In a space game, there is no friction in space, so you probably would leave that off or leave it to a lower amount depending on controllability. Alright, so there you go. That's the basics. Basic two ways that we can move an object, at least in a top-down 2D style game. If you're doing a platform style game, I will show an example of that in a different video, I think. How we can set that up for things like jumping and moving and all of that. But this gets you started. So to recap, you're going to set up your inputs in the input manager, and then you can just store those into some float variables here. And then if you want to move without physics, you can use transform.Translate and transform.Rotate. If you want to move with physics, then you can use the rigid body and add some relative force. And if you want to spin with that, you can use AddTorque. Those are kind of the new commands that we looked at in this video. So I hope you found this helpful. Feel free to leave questions or comments or things you'd like to see me cover in the comments below. And as always, thanks for watching.